Welcome back. This is another exciting episode of Mr. Takeda Teaches Math 7. I'm your host, Mr. Takeda, and I'm going to teach you some math right now. This is lesson 4.3 on solving inequalities using multiplication or division, in which we ask the essential question: how can you use multiplication or division to solve an inequality? The answer is quite simply, just like you would if it was an equation. Almost. And that's a pretty big almost. So let's get started, shall we? All this, you don't have to write all this down in your notes, but I want to talk about this. Let's read together what this says here. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. This preposition is very important. Let's take a look what happens here. So negative 4 is less than 6. This is true. If I multiply both sides by the same, positive 2 in this case, I end up with negative 8 is less than 12, which is still true. And it goes for division as well. 4 is greater than negative 6. Dividing both sides by the same, positive 2, I still end up with a true statement. 2 is greater than negative 3. So when we are dividing by or multiplying by the same positive number, we treat it just like an equation. Nothing, we don't have to do anything different. We just simplify and we're done. And of course, this is also true for less than or equal to or greater than or equal to down here in the bottom. Okay, so let's do an example together. X divided by 5 is less than or equal to negative 3. Okay, so if x is divided by 5, but I want to solve for x, that means I have to multiply that side by 5, because 5 divided by 5 gets me a 1. But I also must multiply the right side by 5. So when I do that, 5 divided by 5 is just 1. So 1x is x, and that's going to be less than or equal to negative 3 times 5, negative 15. Done. All right. So make sure this is in your notes. Please label it example 1, just example 1. You don't have to write this part of it. And then you try this one. We're going to call this one 1T, in case I ask you for the answer or ask you about this question at the end of the pod. You don't have to graph the solution, just solve for M. Pause the video if you need to, and when you're done, hit play, and then you'll join me right here. Actually, this is for in class, so we're going to skip this. This is for later. Example 2. So write down example 2, and this is for solving an equation using division. 6 times x is greater than negative 18. Okay. Now I'm solving for x, which means I want to undo the multiplication of 6. I don't want 6 x's. I only want 1, so I'm going to divide that side by 6. And I must divide the other side by the same number. So 6 divided by 6 is a 1, that's 1x. And negative 18 divided by 6 is negative 3, so x is greater than negative 3. And again, because we're we're dividing both sides by the same positive 6, I don't have to do anything different. I can treat this just like it was an equation. Now, try this one. Pause the video here. We're going to call this 2T for purposes of putting answers into the pod at the end of this video. And when you're done, hit play, and you'll join me, not here, but here. Okay, so now we have a case 2. This is going to be the negative case. And this is where things get a little bit different. Now, this is pretty easy, but the problem with doing math like this is when it's all mixed together and you're not thinking about it. You have to keep thinking about when things are different. When you multiply or divide each side of an inequality by the same negative number, okay, so this is a negative case, the direction of the inequality symbol must be reversed, okay, for the inequality to remain true. Let's look at some simple examples here and why that happens. So I have negative 4 is less than 6, and that's going to be true. If I multiply both sides by the same negative 2, the right side becomes a positive 8, the left side becomes a positive 8, the right side becomes a negative 12. Well, 8 is greater than negative 12, so I have to reverse that inequality symbol around. Look what happened here. The left side started negative, ended up positive. The right side started positive, ended up negative. So, the signs switch, so we have to flip the inequality symbol around because negative numbers are always smaller than positive numbers. The same is true for division. 4 is greater than negative 6. This is true. True. If I divide both sides by the same, negative 2. The right side becomes negative 2. The left side becomes negative 2. The right side becomes positive 3. So I have to reverse the inequality symbol around in order for this to remain true. Okay? So again, pretty simple, and you will remember it, but you have to be looking for it when you're doing a bunch of problems like on a homework or on a quiz or a test. Let's do this one together. I like this problem because it has a fraction in it. I like talking about fractions. Negative 3/2 times n is less than or equal to 6. So I'm solving for n. So what do we do to, how do I turn the fraction into a 1? I multiply by the reciprocal. So the reciprocal will be negative 2/3 in this case. And I must multiply the right side by the same negative 2/3. Okay, so negative 2/3 times negative 3/2 is just a 1. If you don't believe me, check it out. Negative times a negative is a positive. 2 times 3 is 6. 3 times 2 is 6. This is 6/6. And any fraction that divides the same, any number divided by itself is a 1. So this becomes a 1. So this is an n. I'm going to leave the sign alone for right now. Let's talk about how to simplify the right side. Whenever you multiply a whole number by a fraction, well, just divide by the denominator and multiply by the numerator. If you can. Sometimes it gets a little messy. You might need a calculator or something. But these numbers work out real well. Because 6 divided by 3 is 2, and then 2 times 2 is 4. And a positive times a negative is a negative. So this becomes negative 4. And I have to reverse my inequality symbol around. It started as a positive 6, but ended up a negative. This side, the left side started out negative, ended up positive. So I have to reverse that inequality symbol around. Okay? Try this one. We'll call this example 3t for you to try. Label this, put this in your notes as example 3t, because I might want to ask you about this later. Pause it if you need to. This is for in class. And now we'll do example 4. Example 4, well, if you haven't guessed, it's going to be division of negatives. If you haven't guessed, I'm sure you're smart enough to figure out what was left. We've done all the other combinations so far. Negative 3 times z is greater than negative 4.5. So I'm going to divide both sides by negative 3 because we're solving for z. We're solving for z. Negative 3 divided by negative 3 is a 1. So the left side becomes 1z. The right side, negative 4.5 divided by negative 3, a negative divided by negative is a positive. So this is a positive 1.5. And I have to reverse my inequality symbol around because I just divided both sides by a negative number. And just to verify, both sides started negative in the original inequality, but now both sides are positive. So we have to reverse that inequality symbol around to maintain a true statement. Okay, try this one. We'll call this 4t. And this will conclude our lesson right now. So go ahead and get this one to your notes. We'll call this 4t. And I might ask you about this in the pod after the video is over. And the video is over right now. So thanks a lot. Have a great rest of your day. Bye-bye.